Hello, everyone, and welcome to night two of the 2023 Summer Research Experience presentation nights. My name is Courtney Kudra, and I am the program manager here at Headwaters Science Institute. I run the research experience as well as do data analyses for the entire program. A few announcements before we get started today. So the first thing I want to mention is that we do have a digital data camp coming up August 21st. If your student really enjoyed this, or if you know someone else who would enjoy some data science basics and projects, we are starting that August 21st through 31st, meeting once a day for about 90 minutes, looking for high school students. So if yourself or someone you know would be interested in that, definitely check out that link. Another thing is we are open for spring registration for the research experience. So this fall, we are completely sold out. We have no more spots, but this spring, if you or someone you know are really interested in doing a Rockstar project, like a lot of the students you'll see here today, please go ahead and check that out. And in that same vein, for the fall, we are looking for mentors. So if you see a mentor online, if you're a master's or PhD student, and would love to mentor a high school student in this project, I am looking for mentors. So please reach out. You can find more information at this link or email me. And my email is online at the Headwaters email. Once again, my name is Courtney Kudra. So in general, I'll give you a little brief overview of what the research experience was. We worked with these students for the past 2 months to develop their own unique research project that they did their own data collection, analyses, wrote a whole manuscript, and today is their professional presentation. So first up today, we have Cole Green. And as he comes into the stream and we pull up his slides, I'll also mention that we are taking questions from the audience. You should have a comments area, either if you're in the live feed here in StreamYard or if you're watching on YouTube or Facebook. I'd love to hear your questions for our students. So go ahead and please put those questions in, and we'll be looking for them here. And without further ado, I'll go ahead and introduce Cole for this evening. Cole has been a part of our program throughout the summer here at Headwaters Science Institute. His mentor, Sean Wesley, unfortunately was not able to attend with us today, but he did a lot of really awesome research on microplastics in his area, looking at rural versus urban impacts on microplastics. And we're really excited to hear what he has to share with us today. So without further ado, here's our first presentation, Cole Green.
Thank you, Courtney. So this is my urban versus rural microplastic comparison research project. Basically, I'll go over the agenda. I'll be doing the introduction for a brief minute and really dive into what microplastics are, why I chose this, and then look into my methods and how I really did this project. And then we'll go into the data figures and the results of what I've collected, and then look into this discussion and figure out my conclusions. And then finally, with my references and acknowledgements and questions, if you guys have any, we'll wrap it up. All right. For my introduction, my field of study that this was in was water ecology and environmental science. My research question was, how does the proximity to urban areas affect the concentration of microplastic in various bodies of water? The purpose of this experiment was really to figure out the real-world implications of microplastics. I had some previous knowledge of microplastics and the environment as a whole, but not enough, so I really wanted to dive into this and figure it out for myself. And just a brief background for microplastics, they're defined as less than 5 millimeters in length and can often be manufactured or are more commonly degraded from actual plastics. And for my hypothesis, I hypothesized that due to litter from housing and easier access to runoff, bodies of water closer to urban areas will have higher concentrations of microplastics compared to those farther away in more rural areas. For my methods, so to start off, for my steps taken, I really need to do some background research. I had some knowledge of microplastics, but not enough for this specific research project. And looking into it, I needed to really centralize my research on what my question was pertaining to and what I needed to find. So originally I did research, looked into articles, and gathered more information about my topic as a whole. And then in doing so, I needed to choose locations. I'd come up with the design of my project and what I would be testing. I was comparing 3 urban areas to 3 rural areas and 6 sites in total. So I needed to get those 6 sites and choose specific locations that would aid me in completing this process. In doing so, I needed to get urban areas and rural areas. Urban areas are described as having more than 10,000 people per square mile, while rural areas are less than 1,000 people per square mile. So I needed to make sure to have 3 of each of those sites in my project. From there, I gathered my samples in each of those sites. I gathered 29 samples in every single body of water, resulting in 174 samples. And from there, I could analyze my samples and really get the quantity of microplastics I had in total. In that process, I needed to take the vials and the samples that I had gathered in the water, pour it in a vacuum with a filter, and then the vacuum would suck the water through and the filter would produce the number of microplastics. And from there, I could analyze it on a telescope and count the amount of water in the various bodies of water. For my materials, I use telescope, sample glasses, filter, a computer, and vials. And really the purpose of this project was to identify whether or not there is a difference between the two bodies, the two rural versus urban, and then from there take steps and see what we can do. And again, my hypothesis of water was that the bodies of water closer to urban areas would contain a lot more plastic. For my results. So my main findings, my hypothesis turned out to be incorrect. I achieved a p-value of 0.9, which failed to reject the null hypothesis. But in doing so, I noticed a disruption in patterns and really found that Bontempe Lake, which was a rural lake, was sort of an outlier, which I'll discuss later in my discussion. But it was a very interesting process to see and was surprising to notice that my hypothesis was completely off. The statistical test that I used was the ANOVA test that I used to compare the sites. So here are my data figures. Like I mentioned before, I think Bontempe was sort of an outlier. The first 3 I'll discuss are really more rural areas and the 3 sites that I thought would have a lot less microplastics. Bontempe was extremely surprising to find, seen as it had more microplastics than any other site that I examined, and it's a reservoir, which doesn't mean too great of things as we drink from there. But it was surprising to see that not a single sample I gathered had no microplastics, and it actually achieved, one sample I saw had over 10 microplastics on it. As I look into the different rural areas, I see my river in the Samuel P. Taylor River, which really proved my hypothesis a lot more and really was consistent with what I had previously thought, along with the rural portion of the bay, which was in Tiburon. Those had a lot less microplastics, never exceeding more than 3 on one sample, and had many samples with no microplastics on them at all. And then as we look into the more urban portions, which was Lake Merritt, found in the heart of Oakland, surrounded by buildings and cities and people, it had a lot more microplastics than the river or the rural portion of the bay. But if you compare that to the other part of the lake, the other lake in a more rural area, it did have a lot less, which was surprising to see. But if we compare the other bodies of water in similarity, the urban portion of the bay from here, which I gathered at a beach surrounded by houses, did have a lot more microplastics in comparison to the bay that was in a lot more of a rural area with no houses and was a lot more isolated. And the same goes for the Canal River, which is lined up and down with buildings and businesses and houses and had 61 microplastics, whereas the isolated river in Samuel P. Taylor really had a lot less. And so what I gathered from all of this is shown in my graph at the bottom here. In total is the difference that each body of water had in total. And for the most part, it was consistent with my hypothesis if you exclude the fact of Bontempe, which had over 140 to 150 microplastics, which was extremely surprising to see. The interpretations that we can gather from this is that urban areas tend to have more plastic that runs into these water areas. Although my hypothesis was incorrect, I do believe that the more microplastic, and there was a bigger concentration due to the fact of people surrounding it. And then the implications of this, really it creates a everlasting effect afterwards. The microplastic being in the water has a lot of damage to the ecosystem and it affects pretty much everything going on forward, any species, the environment, and especially people. It has a lot of health effects towards people who are swimming or drinking or really interacting with the water any way possible. And because of this, it's really difficult to change infrastructure. So trying to combat this issue is really difficult, as I found in my research. The limitations that I found without this project, as I've mentioned before, I found that Bontempe was sort of an outlier. And I do believe that this was due to faulty analyzation. When I was analyzing my Bontempe Lake filters, I paused and folded laundry about approximately 6 feet away. And I believe that some of those fibers from the laundry ended up floating onto the plastic, therefore causing faulty and misinformation on the filters, which ended up altering my entire experiment. And then adding on to that, I think the location of sampling, I sampled almost everywhere on the surface level water bordering the land. If I was able to go into the middle of these bodies of water and explore the different depths at which I could really sample from, I think it would have provided a lot more in-depth research. And so the recommendations I have going off of my conclusions is that if the water is being frequently used, like many of these bodies of water are, it would be important to isolate the source away from municipal areas, as we discovered that there tend to be a lot of microplastics in these municipal areas. And then along with that, it'd be interesting to figure out filtering strategies and counter the amount of runoff. In my research, I discovered that a lot of these microplastics come from runoff and are exaggerated with heavy storms coming in. And so if you could almost create a sort of filtration system around these bodies of water in order to counter the runoff, would be helpful in creating less microplastics. And then along with this journey, I discovered multiple alternative research projects, which I think was one of the more interesting things to find throughout this process, relating to what I just said earlier, where it would be interesting to explore at what depths microplastics are most present, and then what they do to certain cells in specific species, which was a commonly talked about topic in my research, and then really the origin that these topics are really most commonly at, and how they bleed into different systems. Thank you for watching, and I'd like to give a special thank you to Courtney for aiding me and working with me one-on-one and teaching me throughout all this, and Sean to really helping me lead and discover what I wanted to research, as well as Megan for editing my document and teaching me as well. And then finally, my mom for transporting me and really helping me discuss this through. Does anybody have any questions?
Wow, what an awesome presentation, Cole. That is super interesting. I know I have a bunch of questions. I've really enjoyed watching you go through this project, as microplastics is a really important subject, and especially as you were studying it right out your back door. So as I ask Cole some questions, if anyone from the audience has any, please go ahead and put those in the comments. So for the first one I have is, do you have any hypothesis, or what do you think, how do you think microplastics impact other aspects of freshwater ecology, such as like water temperature or macroinvertebrates?
So I think another student touched on this, was the actual water quality. And because microplastics are so prevalent, I really do think it bleeds into a lot of different water systems throughout anywhere in the world. And really, I think what people hear most when talking about microplastics is its impact on species, and how so many species are ingesting microplastics, and then we're ingesting the species, and how it bleeds from system to system so easily. So I do believe that it'd be interesting to, dive deeper into each one of these topics, is what I was mostly talking about.
Yeah, no, there's lots of things that you can look into. I know that they've found microplastics in like human blood when you get your blood drawn and analyzed. So it's a really important topic. I have a few more questions for you. So the first one, or the next one that I have, is like, how did you define rural versus urban, and how did you come to like this split in your research?
So I think I mentioned this earlier. Rural was defined as less than 1,000 people per square mile, and urban was more than 10,000 people per square mile. And so I had already kind of thought of locations because I did all the research around my house, so I already had ideas of locations that I believed were rural and non-rural. And then in further research, I discovered specific locations and what actually fit versus didn't.
Awesome. I think it's really interesting to look at the rural versus urban. I know that there's another project that had similar interests with water quality. Um, and we do have a question from the audience here. We have a couple of them actually. So starting with Jack Holmes, they stated, what is the size range of your microplastic targets? If you have a size range, so they might not have been able to determine like as to what size your microplastics are, but I think with this question, they're asking like, were you looking at like dime-sized pieces of microplastics, only microscopic, or what other sizes did you come across?
Yeah, I came across almost all the microplastics I came across were all only visible using a microscope. I only had two pieces that were visible with the naked eye. And what was really interesting to find throughout this was that most of them were often fibers, so they were strands of microplastic on the sample and weren't really actual pieces of microplastics. But they were all only visible with a microscope, besides two.
Awesome. That was a great question, Jack. Thank you for putting that up. And I think just for the sake of time, we're going to have to move on to the next student. But thank you so much, Cole. That was such an interesting project. Everyone, please keep using that chat feature. It was great to have your questions. And we'll move on to our next student, who is Ryan Wisk. And I'll go ahead and introduce him as well, as his mentor, Sean Wesley, was unfortunately unable to attend this evening. So Ryan attends Marymount high school, and he's been working really hard with us the past 8 weeks. It's been a joy to have him in class. Very fun to include him in all of our projects and be able to work with him one-on-one. And he's been looking at some another water project looking at streams temperature along with some other factors that I will let him fill you in on. So go ahead, Ryan.
Thank you, Courtney. I did my presentation or my research on the correlation between a stream's temperature and the pollutants within it. So I chose this question because I really wanted to examine the effect of temperature on pollutants that could potentially increase with global warming. My research question was, how does the temperature of a river affect the river's contents of nitrogen, phosphorus, and pH? I knew a little bit about the environmental effects that nitrogen and phosphorus could have, so I was curious on how that could be affected with global temperatures increasing. And if nitrogen and phosphorus could increase, it could potentially create like a positive feedback loop. And my hypothesis was that there would be more nitrogen and phosphorus but have a lower pH in warmer rivers. I thought this because through my research, I found that nitrogen and phosphorus have been seen to increase as temperatures do as well. And I also found that nitrogen and pH had an indirect relationship, leading me to believe that pH would decrease with the increase in nitrogen. So to start off, here's my first location that I took samples from. It's the San Leandro Creek in California, and I chose this because it was in close proximity to me and easily accessible through a hiking trail. And that's pretty much the only reason. And I gathered data there over a spread period of time. My second location was the Ocklawaha River in Florida. I chose this river because it contrasted well with the river in California. Just looking at the locations, they were on opposite sides of the map of the U.S. So it was very far away, and that gave it a lot different elements that I could look at. There was also a lot of data that I could look at, and all the data was provided by the Lake County Water Atlas. So thank you to them. So here are my methods. Before heading to the river, I marked 15 locations and I spread them out evenly along the river. And I did this so that we could get enough information out of the river as needed while not getting the same data every single time. So when I got to the site, I put a thermometer in and I took out strips of nitrogen and phosphorus. and I put them in by dipping them in the water and then holding it for a second or two and then taking it out. And then I would measure them by the strip would have a color on it, and then you would get the bottle and match the color to the amount of nitrogen or phosphorus that was in there. And then pH, I took a vial of water and then I did some test drops, and that changed the color, and then I could look at the amount there. And then after that, I would take out the thermometer and take the temperature, so that I took that at the very end because I wanted to give it enough time to acclimate to the temperature. Here is half of my results and data figures. For every single graph, Data Classroom was used to automatically linearize my graphs. And I chose linear regression for this because it fit well, because we're finding a relationship between two things, and the relationship we're looking for will hopefully be linear. In figure 1, we see the relationship between nitrogen and the temperature. From this graph, it seems to be a direct relationship as the line is pointed upwards, and that the amount of nitrogen goes up while the temperature goes down, or goes up as well, sorry. And the R-squared value for that was 0.568. For figure 2, we saw the same exact thing where phosphorus went up as temperature did. And the R-squared value for that was 0.403, which again shows like a direct relationship, but it might not be as strong as nitrogen. Then here are my other two graphs. And figure 3, things are a little bit different as pH and temperature get put together. We can see a small indirect relationship between them. And according to the Kings Bay Restoration Project, higher nitrogen levels can lower the pH of the water. This means that if the amount of nitrogen increases as the temperature goes up, then the pH should decrease as the temperature goes up. This can be seen in the graph, but it's not that much of a drastic change to really confirm anything, which indicates like it's a small correlation. But in figure 4, provided by a study of nitrogen in waters of India done by the Cochin University of Science and Technology, we can see that the nitrogen goes up, but the pH goes down. This is something to note is that the nitrate is in nanomole a milliliter, which seems like a small number because of the prefix nano, but it's actually very big because if we convert, for example, 4 or 2 nanomoles a milliliter into milligrams a liter, we get 10 for 4 and 5 for 2. This means that as the units are like measuring in quite large, like big pieces, my data does not go up that high, which explains why figure 3 doesn't really have a strong correlation. So what does this mean for us? With global warming increasing the temperatures, it will increase the nitrogen and phosphorus as well. With this increased amount, algae blooms will happen more often. These algae blooms lead to dead zones as they take up lots of oxygen, and then they grow to larger population size, which takes up more oxygen. If nitrogen increases, then the pH will decrease. This leads to increased solubility of toxic metals and death. If the levels of the toxic metals increases, then the fishes could be poisoned by the metals and then die. This also leads to the fishes being more susceptible to fungal infections, which can easily decrease fish populations. And another thing to note is that the shells of many shelled aquatic animals that live in the rivers are also in danger, because as the pH goes up, the solubility of the calcium carbonate, which is what shelled creatures use to make their shells, is reduced, which leads to animals that need shells to not be able to grow their shells. And what could I have done better? In this experiment, I was mainly limited by funding and location. I would recommend higher standard equipment like nitrogen phosphorus analyzers or a titrator to measure the pH. And I would also add more data points from different rivers to get even more accurate data. I would gather data about rivers near urban areas or rural areas and then compare them to get even more data points that we could measure and talk about. And I would also get more data with hotter or colder rivers to further prove what I found. And I would also measure more variables, like variables such as turbidity, salinity, or dissolved oxygen. So this could be measured to, again, find correlations between them and the temperature. I'm super grateful to my fellow student Katya for proofreading this manuscript, and to Courtney Kudra and Megan Joyce for leaving helpful comments that made this manuscript possible. and also on my presentation. Thanks for listening. Any questions? Oh, you're muted.
You know, it had to happen at least once. Thank you so much, Ryan. It's such an awesome project. It's definitely something that I've been passionate about, so it's been really fun to watch you grow through this project and learn a lot. And we do have a couple questions from the audience that I think all of us are wondering. So I'm going to start with Kaylin C's question. And it's pretty simple. How did you get to Florida? From what I understand, you're in California, correct?
Yeah. I actually used so the Lake County Water Atlas is like collects data from different rivers, specifically in Florida, and I pretty much just took their data that they took very recently and used it in my research.
Yeah, that's awesome. That was a great question, Kaylin. And a lot of our students will have databases or data like that. So if you are someone who has access to open source data or is able to put data online, I know our students benefit from it, and students across the country and around the world would benefit from it. And then I'm going to go ahead and ask you one of my questions, but we have some more audience questions. So just be prepared for those to come your way. So you did a really great job. I actually had to adjust this question while you were going through your discussion because you talked so much about how these water temperature differences will impact wildlife. How do you think these water temperature differences or the measurements that you made, what do those implications have on human populations in the area?
Well, so for one thing, if it's in like a reservoir or somewhere where they take water, that's in the drinking water, which might not like be taken out, so that could be number one, harmful. And then I guess also because there's going to be like less biodiversity, less things that will produce oxygen, I guess you could just drown in the air. I don't know. So yeah.
Yeah, there's a lot of things that it could impact for human populations as well. And you had a really good answer for all the wildlife populations. Is really interesting how to hear it, how it would impact the fish or shelled creatures like turtles. I think that Jack Holmes, once again, has a really awesome question I would love to share with you. And he asks, what mechanism would you suppose causes the increase in nitrogen with temperature? Do you have any suppositions on that?
Yeah, I did not talk about this in my presentation, but lots of nitrogen and excess like nutrients like that come from runoff from not urban, like farms and stuff, because the fertilizer they use uses nitrogen and stuff, I think. I don't know, I took apes. So and so that like increases the amount of nitrogen, and then that's pretty much like kind of what I was looking at. So yeah.
Awesome. No, great explanation there. You did such a great job. I have one more question for you. Are you interested in doing further water research? Has this started something new for you, or is this something you started in the past and have continued?
I think this is pretty new for me. I mean, this is my first research like program, anything like that. I haven't done any research outside of school or like any labs in school. And it was pretty fun. I had a lot of fun doing it. It took me outside and I got to go on a free hike. Not free, but I got to go around. I like going on hikes anyway, so it was pretty fun. Yeah.
It's always nice to have an excuse to go outside. Well, thank you so much, Ryan. You did an awesome job. What a cool presentation. And in that same vein, we'll move on to our next student, Madeline, and her mentor, Warren, will be introducing her. And I'll just say a plug here, as Ryan mentioned in his presentation, that if he had more funding and resources, he might have been able to go to different locations or collect more samples. So if anyone is looking for an opportunity to donate, Headwaters is, of course, more than interested. So you could support a student just like Ryan, Madeline, Cole, or anyone else who you'll see online today. So next up is Madeline, and I'll go ahead and let her mentor, Warren, do her introduction.
Hi, so Madeline is from Camp Olinda High School. She was looking at links between Lyme and mental illness in the United States. She took on a really fascinating and challenging topic. I learned a lot by going through it with her. And really, she went above and beyond in all her research efforts.
Hello. As you've already heard, my name is Madeline Tremont, and I'm researching the correlations between Lyme disease and mental illness in the United States. So, for everyone who doesn't know, Lyme disease, also called Lyme borreliosis, is a multi-system bacterial infection of Borrelia burgdorferi. It's a spirochete from Ixodes ticks, which I'm pretty sure most of you know of. They're those little hard-bodied ticks. It is the United States' most common vector-borne illness, believe it or not. And though it is commonly associated with flu-like symptoms in its early weeks, along with that characteristic bullseye rash, there is growing evidence to support Lyme disease having neuropsychiatric symptoms, which for those of you who don't know it, neuropsychiatric symptoms means it has an effect in mental health and mental illness. So, that being said, Lyme disease and mental illness are both increasing. And I'm pretty sure everyone's heard of the term a mental illness epidemic. Mental illness is increasing dramatically across the United States, something that I'll show in my results. And there are many biochemical and infectious causes to the mental illness epidemic that are unexplored. So with that being known, my research question was, to what extent does increases in the rate of Lyme disease correlate with increases in the rates of mental illness in the United States? I hypothesized that there would be an increase and there would be evidence to a trend between increases in Lyme borreliosis and mental illness in states with high pre-existing Lyme borreliosis. So I tested this assumption using 3 NSDUH National Survey of Drug Use and Health mental illness estimates. Any mental illness, which is aggregate mental illness, it could be anyone from like anxiety disorders to like just simple moderate depressive disorders. There's serious mental illness, which is the like more severe subset. It could involve bipolar disorder and schizophrenia, and major depressive episodes, which is a period of time in which a person experiences symptoms of major depression. I also used Center of Disease Control, CDC, Lyme borreliosis rates as provided through the National Notifiable Diseases Surveillance System, the NNDSS. It is a self-reporting system. Basically, doctors, if they think they have a patient with Lyme disease, it's probable or confirmed, they report it. I worked within 2010 to 2018 to avoid the COVID-19 pandemic and definition changes in the early 2000s, and I worked in increased rates per 100,000 per year for that time period. Basically, for each of the states in the District of Columbia, how many more people were getting Lyme disease or these specific mental illness metrics per 100,000 per year. So that being said, for all the researchers here, why rates of increase? Why turn over 408 data points into just 51? This was done for one big reason and a lot of smaller reasons. The biggest reason was I can't go out there in all the states and give people Lyme disease and see if they become mentally ill afterwards. West Virginia and California are completely different places, and I can't. And it's really hard to establish like what is a baseline mental illness without Lyme disease, because Lyme disease has been in many areas across the world for some time, for even thousands of years. In the United States, it's been documented since the 1980s. So through working with rates of increase, I was able to isolate and provide a more of a baseline, seeing how are things growing instead of what's already here. It allowed me to address the delayed manifestations of Lyme neurosis, which is the neurological aspects which produce neuropsychiatric influence. And it also allowed me to generalize variable Lyme data because people are diagnosed, sometimes misdiagnosed or re-diagnosed, and the data itself varies from year to year due to some issues, which I will talk about later. And it also allowed me to address like tick population shifts. Sometimes it's a colder year, sometimes it's a warmer year, sometimes it's wetter or hotter, and ticks respond to that. So that being said, once I had my 54 data points, I separated it into 4 categories: prevalent increasing, prevalent constant, limited increasing, and limited constant. This was because the data was highly bimodal, which means that within the Lyme data itself, like how prevalent is Lyme disease and how much is it increasing, there were 2 big humps, basically very low or very high. So to keep the data from messing with each other, messing with itself, I separated them out and evaluated them using a linear regression. So Here are the average results. Lyme disease increased during this period, on average, about 0.55 per 100,000 per year, which means that across the population of the United States, there's about 2,000 more cases of Lyme disease per 100,000 per year in the United States. For mental illness, in aggregate, it increased around 556.1 cases per 100,000 per year. That is nearly 2 million new cases of mental illness in the United States, like per year. But that's just Lyme disease and mental illness independently. There were notable correlations between Lyme disease and mental illness in all the categories of mental illness evaluated in states that had prevalent Lyme and increasing Lyme, which, if you read the slides, means that it had cases more than 5 per 100,000, and the states increased by 0.1 per 100,000 per year. So that's a big thing. Although it was not quite statistically significant, the highest correlation is any mental illness, the aggregate value. It's 0.07. It does not pass the 0.05 benchmark, but that means that I can't truly disprove my hypothesis, but I can't truly prove it. It means there's something, which is very interesting given the limitations of the study. That being said, the limitations. There were serious CDC data limitations. The CDC and NNDSS, while the most reliable source of data nationwide, is underreported by a factor of 10. There are 30,000 cases reported to the CDC annually but there's actually been estimated to be over 400,000. Like Lyme disease is prevalent, seroprevalent, blood prevalent in 14% of the global population, and it's seriously underreported. There's also, in many CDC high incidence states that have the most Lyme, they don't count the cases anymore. It's considered to be something as a burden to the health department, so they rely on flawed estimation systems, which undermine the data and make it seem like cases are constantly going down, even though it's not actually the case. The NSDUH also does exclude some groups which may be uniquely susceptible to mental illness, like people who are in jail, hospitals, or are homeless. So that is something to keep in mind. Further research is probably the most interesting part of this to me. Since I have a low p-value, more research is necessary to verify if mental illness and Lyme disease are connected in the United States. No other studies have been done like this. For me, if I were to go forward, I would use seroprevalence data and tick testing to get a better count of where Lyme actually is. Like, doctors are not reporting it as much as they should be. And as a result, I'd probably rely on like dog seroprevalence and like tick testing done on dogs because more dogs are being tested for Lyme than people. However, I'd also probably use Medicare and Medicaid data tracking, seeing within a certain period of time how many mental illness patients are being diagnosed with Lyme and vice versa. Studies like this have been done in Denmark, and they have shown what seems to be like a link between, if not mental illness treatment. But that being said, a lot has been going. I've said a lot, and so here's my conclusion, a little wrap up. Do increases in Lyme disease correlate with increases in mental illness? Maybe. It's very interesting to see, and my research is strong enough that more research definitely needs to be done. And the strongest area of interest would be states with both a history of Lyme disease, high Lyme disease, and increasing Lyme disease. Thank you to everyone who helped me with this. Thank you, Warren. I'm sorry I chose such a hard question. Thank you for struggling along with me and making sure that I had the data that I needed. And thank you to Dr. David Layton and Dr. Frank Rames, who helped me in the early stages. And thank you to my parents, and especially my mom. Thank you for your statistics help. With that being said, does anyone have any questions?
Wow. What a great and interesting topic, Madeline. I have loved learning about this with you throughout the summer. And I definitely have a few questions myself, but I'll let Warren go ahead and start it off. Warren, do you have any questions for Madeline?
Yeah, so you mentioned looking at a couple other sources of prevalence, like in dogs, and actually monitoring the ticks themselves. And I was just wondering, is all the Lyme that you're going to be monitoring there the same kind? Do we know that all that Lyme is going to be relevant to the kinds of other pathologies you're looking at here?
Well, the problem is the CDC only tracks a single main infection of Lyme, burgdorferi. The pronunciation is variable, but there's actually there's evidence to about 200 or so co-infections or sub-infections of Lyme, and they're not tracked. They have very similar effects as far as I know, but it's definitely something that needs more research because it's not defined as well as it should be.
Awesome. This is such an interesting topic. Warren, do you have any other questions for Madeline?
I was gonna open it up here because there's a lot to ask.
There is a lot to ask, and I have a few questions for you, Madeline. You've been so passionate in class. It's been such a joy to have you, and I've learned more about Lyme disease than I ever thought I would know, which is wonderful. I do have a few questions about your research, but also a few questions about your future plans in this field in general. So I think the first question that I want to ask you about is, I remember when you were first looking at your research, there's a lot of variance in the different states in the data that was available. And you did speak about this a bit in your presentation, but I just wanted to give you an opportunity to speak to that a little more and talk about how that may have skewed or impacted your results or your research in general.
Well, I spoke about how the data is highly bimodal, and I was not kidding. The range is basically from 0.2 cases per 100,000 to 100 cases per 100,000. And it's the same, like even greater degrees with increasing. The highest state, Rhode Island, increased at a rate of 13 cases per 100,000 per year. And the lowest state was -8 cases per 100,000 per year. There was huge range in the data. And states, and it's a reporting issue. People assume, some states suggest that there's overreporting in high incidence states. I wouldn't believe so given the state of Lyme, and underreporting in low incidence states, which is definitely true. There is no way that there was one case of Lyme disease in Mississippi last year. No way. I'm not going to believe that.
No, that's very, very true. I remember you speaking to that earlier in the program in general. We do have a question from Jack in the audience that I would love for you to talk about a little bit. And it's, what are some of these mental health symptoms that you were looking into? I know you listed a few, but if you go ahead and talk about that some more, that would be awesome.
The most common symptom actually most common symptom and very close symptom associated with PLDS patients, which is post-treatment Lyme disease syndrome. It's a bit different from Lyme disease itself, but it's the most notable one because it's the most common one that's listed even in active Lyme disease, is symptoms close to major depressive disorder. Like think about that brain fog, that lethargy, like everyone, like you feel down. That's one of the biggest symptoms, but there's also associations of anxiety, depression, bipolar disorder, rage. It affects everyone differently because it's not a very specific illness. It's a multi-system disease. Like chronic Lyme disease can manifest in your joints, causing arthritis, or like it can cause meningitis. It goes everywhere and does basically anything. It's called a great intimidator.
That is such a good answer. And I think it kind of flows into this next question that is not necessarily about your research, but more about you. And how likely are you to continue this research into the future?
Well, it's something I always say is that researchers, if they're researching something like and doing it a lot, they either have a passion for it or a vendetta. And I have both. So I am thinking about pursuing like research into immunology and potentially into Lyme disease in college. But it's just a path that I'm thinking about for now, but it is definitely something that I'm giving some serious thought to.
Awesome. And that's all we can ask for you for now, right? So you did such a great job. It was so interesting to learn. This is definitely such an intersectional topic. And thank you so much for sharing with us, Madeline. And I'll go ahead and introduce our next student that we have coming up, who is also one of Warren's mentees, and her name is Bella.
All right, so Bella goes to Manhattan High School for Girls, and I just want to say she was working on air pollution and solar energy generation. She has a really impressive scientific curiosity. She was looking at local data and looking at the world around her, and looking at the air pollution that the East Coast experienced earlier this year, and came up with a really interesting research question. So, Bella, take it away.
Hi, everybody. As Warren mentioned, my name is Bella, and I studied the correlation between PM 2.5 concentration and solar energy production in Brooklyn, New York. So my question was, does PM 2.5 concentration affect solar energy production? PM 2.5 is particulate matter that's 2.5 microns or smaller, and it was measured in micrograms per square meter. The solar energy was measured in kilowatts per hour. So the reason that I did this research was to find out the most effective place to install solar panels. And this is really important because climate change has been an ever-present problem that has been increasing over the years. And one thing that it causes is wildfires, because when it becomes warmer, it's easier for wildfires to start. And actually recently, on June 7th, 2023, there was fires in British Columbia in the west, all the way to Quebec and Nova Scotia in Canada. And the smoke from those fires traveled down and covered New York, and PM 2.5 levels have skyrocketed around June 7th. So that is what inspired me to do this project. But because there is so much air pollution, if my hypothesis proves to be correct, which is that the PM 2.5 will negatively affect the solar production, then there may be a vicious cycle of climate change and less solar production, which will make people more likely to use fossil fuels, which is what causes more air pollution and then climate change. So in the pictures on the bottom, you could see how it looked when there was high levels of air pollution. So in the right picture, that dot over there is actually the sun, which kind of looks different, which is what made me think that it will affect PM 2.5, solar energy production. So my methods were to make a linear regression of the PM 2.5 level and solar production, and I would see whether they have an effect on the solar production. On the left is a picture of the solar panels on my house, and those were provided by SunPower, which is where I got the data from. The PM 2.5 data was from the EPA's website, and then to put into context whether the PM 2.5 levels actually had an effect on solar production, I also tested cloud cover and wind speed with solar production, because cloud cover obviously has a very high effect on solar production, and wind speed was said to have a low effect on solar production. So I would see where it falls in the scale of very like it has a high effect or has a low effect, like wind speed. And to make sure that time of year did not affect my results, I split up all the data into 4 sections corresponding to the 4 seasons, because time of year should have an effect on solar production because of the way the Earth tilts on its axis. So the first of all, it has during the year there's different amounts of sunlight every day, and also because the Earth tilts during certain parts of the year, New York would be closer or farther from the sun, which will affect solar energy production. So my results were that when I isolated that 1 month where we had very, very high levels of PM 2.5, it had a strong effect on solar production, but when it was only split up into the 4 seasons, when it was with a group of 3 months in spring, it did not have a strong effect on solar energy production. Wind speed was super interesting because it was said to have no effect at all, but it had a very strong effect in spring and fall on solar production, but in the summer and the winter, it did not have a strong effect. And cloud cover, of course, had a strong effect on solar production, and all of this was graphed using linear regression. So over here are my data figures, and the first thing that I tested was temperature from the whole year to solar production, and I use temperature as a proxy for time of year because the temperature will vary during the time of year. So because there's a strong correlation, because the p-value was less than 0.01, this shows that the time of year does affect the solar production. Then I tested the PM 2.5 concentration against the solar production, which in March through May had a p-value of 0.74, which is really bad. So it has basically no correlation. And then in the remaining 3 months, the correlation was little to none. So it still didn't have a very high effect. But then over here, when I did just May 21st to June 14th, which was about 25 days, the p-value was 0.05, which has a pretty strong effect. Over here is cloud cover, also split up into 4 months, and all 4 of them, they had a p-value that was less than 0.01. So of course, it had a very strong effect on solar production. Over here is wind speed, which had in June through August, which is summer, and December through February, which was winter, had in the summer it had basically no effect, and then December through February it had little to no effect, and then in March through May and September to November, which is fall and spring, there was a very strong correlation. Just to recap on my results, the PM 2.5 had a significant effect when the PM 2.5 levels were high, and then when the PM 2.5 levels were regular in Brooklyn, which was generally under 50 micrograms per square meter, the effect couldn't really be seen. And implications were that solar panels will produce less energy when the levels of PM 2.5 are very high, and won't have such a great effect when the PM 2.5 level basically stays the same. So some limitations that I had doing this project was that I didn't have a lot of high PM 2.5 data. It generally stayed pretty low. I also had only 1 set of solar panels that I got my data from, so it may have been biased. I was also missing data when I used the EPA's air quality data. They didn't have May 31st, 2022 and the whole January 2023. And also when they were recording their data, they kept on switching stations that they were recording their data from, so that may have also introduced some bias. Some recommendations that I would do to further research would be that I would test it in a place that has higher levels of PM 2.5. So maybe a place in California that's exposed to wildfires that they have pretty often. I also may want to test some other pollutants in the air and their effect on solar production. And maybe do some more tests with wind speed and see why the wind speed had such a strong effect in the spring and fall, which my hypothesis would be that it has something to do with cloud cover, because wind speed may be correlated with storms that clouds are also correlated with. So that might have something to do with it, but it would definitely need some more research. I would like to acknowledge my mother, who helped me find databases, and my father, who helped me with the statistical analysis. My grandfather also helped me with deciding on a research question and supporting me through my project. I would like to thank Courtney for doing this, for teaching us in class every week, and Headwaters for arranging this class. Also to my mentor, Warren, for helping me through this project and basically everything. I would also like to thank Jennifer Hepner and Stone for peer reviewing my manuscript. Does anyone have any questions?
Wow, Bella, what a cool presentation. And I know you may not have been able to see all the questions come through from the audience, but they definitely have a lot of questions, and so do we. But I'll go ahead and let Warren start us off with his question, and then we'll move into some others.
Yeah, so I'll just jump in. So you had sort of the unique problem of working with a very local data set, and from your own house, and then working with some larger government data sets. I was just wondering if that presented any kind of unique challenges, or really what the most challenging part of this process was.
Yeah, so it did present a little bit of problems, because when we found the data, it's over the whole entire Brooklyn, and my house data was just from where I was, but I think it was pretty accurate. It's better than if I would have found for the whole New York State, which would have been much less accurate. But yeah, definitely the biggest problem that I had was trying to clean up the that data, which you helped a lot with. Thank you. And yeah, because it had the whole different stations and the switching stations and the missing data, which had to be accounted for.
What a great question and a great answer, Warren and Bella. We have a lot of questions from the audience here, so I'll go ahead and start with one of those, and we'll start with the first one that came through, which your screen name is I am Halo, so we'll go ahead and say Halo is asking you this first question is, do you think there is a renewable and safe way to stop these problems? And I think just to give you more specificity on this is the impacts of the wind speed and or the wildfire smoke on the solar panels. Do you think there's any strategies we could take to possibly manage some of those?
So,
and I see that Halo is Elliot. Go ahead.
So I would suggest, obviously, we're all trying to do this and start switching to more renewable energy sources, like solar panels and windmills, which is really interesting because wind speed did play a role in affecting solar energy production, which will be interesting if you also try to switch to more windmills instead of fossil fuels. But I think it's just it's a process to switch. So just using the renewable energy and finding the most effective way of installing them so that they're most effective will help people want to use them more, and for them to be more effective.
Yeah, that was a great answer, Bella. We have a few other audience questions. The next one that I want to share with you is from Jen Cotton. She's asking, do you notice any difference in your household with solar panel productivity? As you pulled a lot of this data from your own solar panels, do you notice that in your household? Is your hairdryer not quite as strong when you don't have quite as much solar panel productivity?
No, we don't, because basically when we produce electricity, it goes straight to the company, and we get credit for when we use the electricity. So basically, all the electricity that we get is actually coming from the company itself, and when we produce extra, we get credit for later. So it doesn't work that way.
No, that's an awesome explanation of that. I know a lot of companies in New York, I know California, the same way, do something like that for those of you interested in any sort of solar panel installation. And we have a few more questions from the audience that I think are going to be so awesome for you to answer. So the next one we're going to look at is from Jack Holmes, and it states, would you in future work be able to get a daily average of kilowatt hours and 2.5 concentrations for a specific set of sites?
So for the kilowatt hours, I'm not sure about other solar companies, but SunPower, when you install solar panels, you get an app where you could see your production and how much you use. And there's on their website, you could download your own data into like a spreadsheet, and the 2.5 concentration. So I got it from the EPA website, but I know that Purple Air has something. I wasn't able to get the data from them, but I think if you install your own machine, then you might be able to get the data from there. And I know that it like gets uploaded to the cloud. So if you put your machine next to your solar panels, that may be a helpful way to get the data for your specific site. But yeah, I also know that Stone, who's going later, he used his own machine that he used. So you could probably buy your own machine and test it where you're getting your solar energy.
Yeah, no, absolutely. That was a great answer, Bella. And you are correct for anyone looking to have a Purple Air air quality monitor. Purple Air is a free online open data set that a lot of our students use. And I believe that Stone, as he'll speak to later, may have used one of those monitors in his own project. But if you're interested, you can definitely purchase them online, and it's a great data source for anyone looking for the open set of data. We have a few more questions here. So we'll go with the next one, which is Jennifer Cotton or Jen Cotton. And she's asking, do you think snow cover or other storms might have similar impacts on your solar panel energy collection?
Yeah, so snowstorms probably, because it obviously comes with some cloud cover, and I can't imagine snow covering solar panels could do anything good to them. So yeah, I should probably look into that. I know that we haven't had so many snowstorms in the past few years, so that would be something interesting to look at. I've never thought of that. But I also I did have an idea. I thought that precipitation would clean the solar panels so that they would produce more energy, but I don't think that's actually true. But that would be something else that I would probably want to test.
Wow, Bella, it looks like you could make like 6, 7, an infinite amount more projects from this one project. You did such an awesome job, and I think we could continue on questions with your specific project for quite some time. So I'm going to cut it off there, but thank you so much for your wonderful presentation and answering all of those questions. You did such a great job. We'll move into our next student, who is Katya with the same mentor, Warren, here. But before as she's coming on screen and pulling up her presentation, I'm just going to send out some reminders. If you have any comments, questions, encouragements you want to give the students, please go ahead and put that in the comment section. If you're on YouTube or Facebook, you're welcome to do that. Or if you're in the StreamYard audience link itself, you should be able to do that as well. But without further ado, I'll go ahead and let Warren introduce his student, Katya.
Yeah, so Katya goes to Valley View Charter. She was working on leopard shark mortality in the San Francisco Bay Area. She was a really highly motivated researcher and brought a lot of contagious passion to her research. So I found myself getting excited about her work too.
Thank you, Warren. Hi, my name is Katya. I've been studying leopard shark die-offs in the San Francisco Bay. So here's my agenda. I'm just going to cover the basics, introduction, hypothesis, method, results, discussion, conclusion, and acknowledgements. Hopefully I'll have time for questions in the end. So first, what is a leopard shark? So a leopard shark is a part of the elasmobranch family, which is sharks, rays, skates. They're endemic to the Pacific coast of North America, meaning you can only find them there. Of course, they have this distinct pattern on them, a leopard print, hence their name, and they have an important ecological role. Basically, in the San Francisco Bay, they eat the most numerous species, which allows other species the chance to grow more in number as well. So, the problem is that leopard sharks are dying. So over the past recent years, we've seen isolated spikes of shark deaths, which isn't normal, meaning it's not natural. Most deaths are in May, with one spike in February in 1 year. So as you can see here, in the Berkeley Aquatic Park, I got this map from iNaturalist. There's kind of like a cluster of deaths in this closed off area. That kind of also proves that it's not very natural. So why do we want to help these sharks? Well, as I mentioned earlier, they're important to the San Francisco Bay. They help keep the population balances in check. Also, they're part of the elasmobranchs, which can be part of a bigger problem, meaning other elasmobranchs can have the same problems as leopard sharks. I know for a fact rays are suffering in the same way that leopard sharks are. So my hypothesis, why are leopard sharks dying? Based on past research and articles that I've read, my best guess was that weather effects, especially precipitation, had something to do with leopard shark deaths. Okay, method. So all of my data was taken from iNaturalist. We only used the years 2017 and up. That's what I meant by recent. The data was only taken from the San Francisco Bay, and I used linear regression graphs to show the correlation. The factors I checked for correlation were the monthly water temperature, monthly air temperature, and annual monthly and seasonal rainfall or precipitation. Okay, so here are my insignificant results. So first I compared monthly average shark deaths to monthly surface water temperature, and that gave me a pretty low correlation. I used R-squared to show correlation, and a 0.5 I would consider as a positive correlation. This was 0.0319, so that's very low. Next, I compared monthly average shark deaths to monthly average air temperature, and that was a little higher, but still pretty low. It was a 0.0411. So here are my slightly better results. So first, I compared monthly average shark deaths to monthly average precipitation in San Francisco, and it was higher than the previous. It was 0.1607. It kind of starts to rise here. Then I compared total number of shark deaths to annual precipitation in San Francisco, and that was 0.1611, still pretty low. And finally, I compared the number of shark deaths to seasonal precipitation, which is about November through March, and that was above a 0.5, so it was 0.5619. Yeah, positive correlation. So discussion, basically, my hypothesis was right. The seasonal rainfall showed the highest correlation. In San Francisco, the rainfall season is about November through March, which it happens to be the leopard shark mating and pupping season. So what I've found is there's always a significant amount of rain before large shark mortalities. That's what's happened here. So basically, this happens because of after rain, there's always a lot of gunk washing into the ocean, which can make leopard sharks more susceptible to disease. That's the first reason. Another reason could be that leopard sharks are getting trapped in places like this that have floodgates. During their mating seasons, they swim into shallow and warmer areas, places like this, and then floodgates close, kind of trapping them in dirty water. Maybe there's not like enough oxygen, or there's parasites, or so the third reason could be that when rain comes, the water rises and sharks swim much further inland than they're supposed to. And either the tides go back and they get stuck in places, or they just are too exhausted, or they have parasites and are infected and too tired to swim back to deeper waters, and they just die. Anyway, results were not taken before 2017 due to lack of observations. When we tried to exclude 2017, it actually gave us higher correlations. So everything lined up with what we were expecting. For the future, though, I think looking at tides would be a good idea. Storm activity too, salinity count definitely, bacterial count, El Nino effects, and I think a better source of data would help the project because iNaturalist does lack in observations. That's why we had to take 2017 and higher. Expanding to other species, other elasmobranchs like rays and skates and other sharks too. Preventative measures should definitely be looked into. Maybe like putting nets in areas that sharks could be potentially dangerous to sharks. Okay, so my conclusion. So here's kind of a little wrap up. Sharks have been dying in the San Francisco Bay. We used linear regression to find different correlations to shark deaths. And like we thought, the highest correlation we found to leopard shark deaths is seasonal precipitation, which is the November through March season, which is also the leopard shark mating and pupping season. Okay, so I used 38 references, which are very helpful. And here are my acknowledgements. Oh, that's messed up. Okay, so I would like to give a huge thanks to Sean Van Summeren. It was a personal communication. He helped me with a lot of my ideas. Megan Joyce and Courtney Kudera were also super helpful in times which I had a lot of questions. And I think my mentors, my mentor helped me like a lot. Warren and one of my co-authors, David McGuire, was super helpful. And also my peer review buddy, Ryan Wisk. I really appreciate their help. Okay, any questions?
Awesome job, Katya. That's such an interesting project. I know that there's lots of research being done on sharks in the San Francisco Bay, and this is definitely something new and innovative to add to that repertoire. I'll go ahead and as usual, let Warren start off with his question first, and then we'll move into my questions and any other audience questions there may be.
Yeah. Are there any particular solutions that you think would be a good area to research? Because it seems like there might be some anthropogenic factors in these shark deaths. So.
Yeah. So I think before I even like get into solutions, we need like more volunteers observing like different shark deaths. I know I've talked to several people and they say that there's just not enough people to get like looking around the bay for shark deaths. So I think that would definitely help research and start finding solutions.
Awesome. Yeah, definitely. If anyone is in the California Bay Area, as I know a lot of students and possibly those watching may be, definitely be using those kind of community science platforms such as iNaturalist, like Katya used in her project, to be sure to include that information. I also have a question for you, Katya, and it is, how do you think these shark deaths are impacting the rest of the food web throughout the San Francisco Bay?
Well, I think if leopard sharks died, then like certain species would blossom, and then those species would start to eat another species, and that could make them extinct. And we just don't know what would happen if they would die, and I don't think it's a good idea.
No, absolutely not. Any form of biodiversity loss could definitely lead to a lot of other domino effects down the line. Warren, do you have any other questions for Katya, or are there any other questions from the audience?
Yeah, well, I was going to ask you how you mentioned some other elasmobranchs like rays, rays and skates. Do you know if they were having die-offs around the same time, or were their die-offs sort of on any different pattern?
I think I've talked with several people, and I know that rays were having the same amount of die-offs around the same time, but I didn't look a lot into it.
Awesome. Sounds like a project for the future, possibly. Katya, do you think that there's any chance you'll continue with this sort of research, marine biology, into the future?
Yeah, definitely. I've thought about adding different rays and skates and other species of sharks and making kind of this big database for a separate. It's called Shark Stewards. Yeah.
Well, that's super awesome, and we're very excited to see what you're able to do with Shark Stewards or more research into the future. I've definitely learned a lot about sharks, and am so excited to see where you go further into this research. But we'll go ahead and make space for our next student and presenter, Savine. He has the same mentor once again, as you can see a pattern here, and Warren will be introducing him. But before we start into those introductions, I would like to make a comment on Savine's project in general. He has done a very unique project, going more of an engineering route in his passion for science. So if you notice that his presentation or results might look a little different, that might be why, as he did a more engineering level project in his scientific research. So without further ado, I'll go ahead and let Warren introduce Savine.
All right, so Savine attends Mountain View High School, and he took on a really novel analysis looking at the environmental impacts of different kinds of battery production. He took a classic analysis, the internal combustion engine versus a battery electric vehicle, and sort of took that into the next future step. So it was a really interesting analysis.
All right, so I guess I can just start. So this is my research project. I'm Savine Agarwal, and my mentor was Warren Staver. So first, on the introduction, what was my topic? My topic was electric vehicle batteries, and the reason behind this was the popularity, because electric vehicles have recently been gaining a lot of traction within just the car community in general. They've been becoming a lot more popular. We see companies like Tesla starting to pop up and like really make an impact. And then also because of sort of the necessity behind electric vehicles, as we know, gas cars aren't going to be they're slowly being phased out as like we've seen with the California gas car ban. So electric vehicles are the future, and it's important to know their own environmental impacts within the battery, because that's a main concern for electric vehicles, the actual battery process. So what I decided to research was figure out which type of car battery would be the best for the environment. So basically create the least amount of impact while factoring in how long the battery actually lasts, like how long this battery will be able to work for in a car. So I compared two different battery types, lithium phosphate iron batteries and lithium cobalt oxide batteries. And these two, I thought that lithium phosphate iron batteries would be better for the environment, because as the name suggests, these are made of iron and phosphate compared to cobalt batteries. and cobalt is obviously a rarer material compared to iron, so it would probably create less impact. So how I attacked this was basically calculate an environmental impact ratio for each battery. And then this would be for water usage, CO2 emissions, and energy usage. So this ratio would pretty much be the amount of impact that 1 kilogram of this type of battery makes over how much energy it would output in its lifetime. So I got these numbers from a model called GREET from the government, which tracks these types of technologies and how much emissions they create. And then as a side note, I decided not to consider the anode of these batteries. I only looked at the materials of the cathode creating impacts. And this was because the anodes between these two batteries are virtually the same. They're both made of graphite. So the impact wouldn't make a difference in which battery is actually better. So see here, I calculated the environmental impact, which was by finding the impact. So this number would be from GREET, the impact, and then basically the percent of the battery that's actually cathode. And then my lifetime energy output was calculated through finding how much energy that 1 kilogram of battery could actually hold, and then figuring out the number of times it could be discharged and charged, and multiplying those two to see how much energy it would output in its lifetime. So after that, I divided those two values, the environmental impact and the lifetime emissions. So these varied units were milliliters for water, grams for CO2 emissions, and kilojoules for energy usage. And then basically whichever number, whichever battery had the lower environmental impact ratio, that would be the better battery in that scenario. And that would be because it's lower, so it's sort of producing less impact per energy output in its lifetime. So here are my results. So first I used table 1 to compile all my raw values, which were sort of from the GREET model, and then also the specific energy, which is how much energy that battery can hold, and the charge cycles. So I first compiled those values in table 1. And then using my previous equations, I calculated the environmental impact and lifetime output here and compiled them into table 2. Finally, I divided those two values and then compiled them into this table here. And then from the results, it was pretty clear that LFPs were better for the environment as I hypothesized. We can see compared 490 milliliters per kilowatt hour compared to 60 milliliters per kilowatt hour. So in this case, LFPs were pretty clearly the winner. So the reasoning for this, as I previously thought, was of course due to the lack of critical resources in an LFP. So an LFP, again, it's made of iron and phosphate and it doesn't have any cobalt, which makes it create a lot less of an environmental impact. Additionally, and then also some possible source of error in my calculations could be the capacity of batteries not changing, as these batteries tend to lose a capacity, how much energy it can actually hold throughout its lifetime. But because I kept the capacity the same for both batteries, it shouldn't have made too big of a difference here. Additionally, I only examined the cathode, but that was, of course, due to the graphite anode being virtually the same. So from this, I figured that LFPs should be obviously used more often in the electric vehicle market. And thankfully, this is already happening. For example, we can see LFPs reaching their highest market share ever in the past decade at about 30%. And we can also see car manufacturers such as Tesla starting to use LFP batteries in their cars. Some possible changes to this study could be examining the whole battery. So that would mean including the anode, and then also including more battery types. So in my study, I only examined lithium phosphate iron batteries and lithium cobalt oxide batteries. But I could also next time add in more batteries that are also used in different car types. So I would like to thank Courtney for being an amazing teacher throughout this and teaching us the scientific methods and scientific process. And then I would also like to thank my mentor for Warren for always basically helping me think through all of the calculations that had to be done here. And then lastly, I'd like to thank my parents for always keeping me on task throughout this whole work. Yeah. And then here are my references where basically I got my data from GREET and such. And yeah, any questions?
Wow, what an awesome, awesome project, Savine. I know that this will definitely impact my electric car choice in the future as that becomes more prevalent. And I'm really excited for us to be able to ask you a few questions, starting off with Warren.
Yeah, the one that stands out to me is if LFPs are so much less, they're not nearly as hard on the environment as LCOs. Why are they only at a 30% market share? It seems like they should be taking over. Any thoughts on that?
Yeah, that was definitely interesting. I think because cobalt has been like one of the main batteries, like LCOs were sort of developed earlier than LFPs. So that could be part of it. Maybe they're a bit less efficient. So that's part of that. And then also, I guess so as they sort of come into the market, especially with electric vehicles, we're sort of seeing them, as I sort of mentioned, slowly become larger. And companies have obviously seen that they're better. And then also, I haven't researched this fully, but a cost could be a part on this. So maybe LCOs cost less money. I, of course, don't know that, but that could be a factor in this.
So for your next analyses, you'll be doing an economic comparison between the two batteries?
That would definitely be interesting, yeah.
I have a question here, and it is, how do you think that these results and this information, this battery information, could inform other battery usage, such as batteries in like electric devices, and or like the larger storage batteries that they use for solar panels, kind of what Bella's project was talking about? Do you have any thoughts on that?
I think that sort of depends on like what the battery actually is doing, because for example, if you were storing a battery, you might want it to be really like, if you were say storing a power wall for your home from like solar energy, you'd probably want a battery that's really safe, that doesn't lose charge capacity over time. But compared to like a cell phone, for example, you'd want the phone to be able to output a lot of energy in a small amount of time. So I think it really depends on the type of battery. So for overall environmental impact for these two batteries, it definitely gives some pointers, but for actual usage, it's a bit different, I'd say.
Awesome. No, it's definitely something to consider and very interesting as you go into this battery realm. We do have a question from the audience from Christy Rollinson, and she says, great presentation, very informative. Did you consider including the manufacturing process and battery disposal as part of the total environmental impact?
Yeah, so I did include the manufacturing process. So if you can also just download the GREET model and then look through it, it basically goes from basically the manufacturing to the car. So it measures the whole impact from there. It doesn't measure battery disposal, which could be another part of a study if I were to do it again. But it does measure like from the ground basically to the car.
Awesome. No, great questions. Great answer, Savine. Warren, do you have any other questions for Savine?
There we go. Muted there. Yeah, well, just to jump off that last one, did you consider recyclability at all? Because when we talk about something over a full lifespan, part of that might be reducing the costs of manufacturing the next one.
Yeah, that's definitely an interesting part, sort of like how you'd be able to factor that in. It was a thought for me at some point, but because of time constraints, I decided not to include it. But definitely, if I had more time, I would have tried to include that.
Awesome. What a great way to expand on the project into the future. I did a great job, Savine, and there's definitely a lot of initiative you had to take with this unique project. And I have learned quite a lot, as I'm sure a lot of our audience members have. But with that, we'll move into our next presenter, Stone, and I will be introducing him as his advisor. Is unable to make it this evening, but she has sent me a few notes to include in Stone's presentation and introduction. So Stone's advisor is Jennifer, and Jennifer is a PhD candidate at the University of Nevada, Reno, studying anthropogenic effects of urban wildlife, specifically birds in Reno, Nevada. And her introduction for Stone reads as follows, is that she had the biggest pleasure mentoring Stone, who attends Mountain View High School. Stone was extremely motivated from the beginning in understanding how air quality and other climate change related factors affect humans and our quality of life. He has come up with an extremely relevant question to all of us and even went out of his way to collect his very own field data. Please enjoy and learn from Stone's project, Effects of City Land Use Types of Air Use on Types of Air Quality. You're muted, Stone, so go ahead and click your microphone. Happens to us
Sorry.
all. No worries.
Yes. Thank you, Courtney, and also Jennifer for writing that. And yeah, as stated, my name is Stone Tugendreich, and my research paper and slides are about the effects of city land use types on air quality. And all this research was taken in Mountain View, California, and that's also where I live and go to school. This is the agenda, and yep, guess what I'll be going over during these slides. Every terrestrial organism depends on air for survival. However, poor air quality can be detrimental to the health of humans, plants, and animals. Air quality worsens around the world due to an increase of fuel emissions, which is evident in our bustling and busy cities. The most common ways of measuring air quality are AQI and PM2.5. Air Quality Index, also known as AQI, measures non-visible gases, while PM2.5 are measures of fine air particles, including sulfate, nitrate, and others. On the other hand, a great way to reduce air pollution in cities are trees. In the United States, urban trees have been shown to reduce hundreds of thousands of metric tons of air pollutants from the city and from the air in the cities. The way people use cities differs between each sector of a town. Therefore, I wanted to ask the question, does air quality differ across different city land use types? If air quality does differ across city land use types, then parks and recreational areas will have better air quality compared to the downtown and industrial zoning codes due to the higher abundance of trees and the reduction of cars. I identified 4 different city land use types around Mountain View, California. I included 8 sites in the 4 different land use types, including public facilities, public parks, public facilities also known as public parks, precise plans, also known as downtowns, industry, and residential districts. Using a Temtop indoor air quality monitor, shown on the right, I measured the PM2.5 and AQI of the air in 2 different areas of each site within a 6-yard or 20-foot area. Over a 2-week period, I visited each site and took the same measurements 2 times for a total of 32 replicates. I ran a NOVA test to see differences in average PM2.5 and AQI units between the zones. Between all the city zones, there were no differences except for public facilities. Public facilities had lower overall AQI and PM2.5 units compared to the other groups. Public facilities had a p-value of under 0.05 in relation to the rest of the codes, meaning there wasn't any chance involved in the findings. Here you see 2 figures of the air pollutant measurements across the 4 city zoning codes. The x-axis shows 4 different city zoning codes: parks, industry, downtown, and residential. The y-axis represents either PM2.5 or AQI. On the left graph, the figure shows the PM2.5 data of each site and zoning code. Industrial, precise plant, and residential all have around the same average PM2.5. However, public facilities showed significantly lower PM2.5 units compared to the other zones. And here on the right, the figure shows AQI data of each site and zoning code. Again, industrial Precise Plan, and Residential all have around the same average AQI. However, public facilities showed significantly lower AQI units compared to the other zones. However, there may have been some errors in data collection, such as limitations on the device used and wind. The device used was on the cheaper side and is meant to be used indoors, which may have led to false data points. Wind also varied, as the amount of wind could have brought air pollutants closer or farther away from the device. Though this data does show differences in air quality across an urban environment, it doesn't explain the method of what causes the difference. I hypothesize that the higher abundance of trees and lack of gas-powered cars causes the major improvements to the air quality. If this is true, then cities could create additional parks and green spaces to help minimize air pollution in urban areas. Though many areas of this research topic were covered, many sites are not covered in my data and could be explored further. Here are the references I used throughout my slideshow, as well as in this presentation. And thank you to my parents for driving me to the research sites and paying for my air monitor. Thank you, Warren Staver and Bella Kundin, for providing me with peer review while writing my manuscript. And thank you to my peers and teachers in the Headwaters Institute for giving feedback during class and helping me along while writing my manuscript. And also, thank you to Jennifer Hepner, my mentor, for enabling me to create an amazing project and guiding me in an unfamiliar field that I had never worked in before. Any questions?
Great work, Stone. That is such a wonderful project. I can see that you learned a lot, and it was such, as you said, like a new project for you. It's been wonderful to watch you write your manuscript and collect your data throughout this program. Jen also sent over a few questions for you. So while I would love to take credit for these amazing questions, I'm going to go ahead and give credit to Jen. So the first question that she has for you is, why do you think residential areas of your city, which may have more trees and yards, had just as high AQI and PM 2.5 as, say, the downtown areas?
Well, in the areas that I took them, I know that many areas in my city have enclosed neighborhoods that aren't near any busy roads, but where I took my measurements, they were close to some of the major roads, which could have led to a lot of fuel emissions and other contaminants from the cars being tracked in the data points.
Yeah, awesome. Great answer, Stone. The other question that Jen has for you is, if you could do this study again, what city or cities would you like to look at and compare, and why?
Well, I would definitely say San Francisco, since I've spent a lot of time there, as well as Los Angeles, since I know, well, just being around there, the air quality is really bad. And I think it would be a great, like, research topic to actually try to fix that poor air quality and compare San Francisco and LA, since they're both in California, but really are so much different from each other.
Wow, that sounds like you could really take off with that project and looking into it. One of my questions for you, which you might be able to tag on to future studies if you're able to pursue this in the future, is have you considered cross-examining this information that you have with the AQI and the parks and the different zoning areas? Have you considered cross-examining this with socioeconomic status or other like social science statuses that would throughout the area of your studies?
Yeah, I think that would be a really interesting area. I haven't really looked at that really at all, but yeah, probably in maybe um I guess near like more of the fancier apartments, or maybe in higher end like neighborhoods, they have more open space because they have more parks and more like like um lawns and backyards, so that might improve air quality, while in like more constrained housing areas, it might be like there's less green spaces since they have to fit more houses.
Yeah, absolutely. No, those are some great answers to your questions. And I think you did a great job on your presentation. I definitely learned a thing or two about AQI in general, and it's another plug for that Purple Air data base that we were all able to get free information at. If anyone's interested in installing a monitor on their house, I think it's about $30 to purchase a monitor and install it. And if there aren't very many data points in your area, that's because there aren't monitors. And it's great for students like Stone or other students that have used it throughout their projects that you've heard about tonight. So thank you so much, Stone. As we move into our very last presentation for the night, I'll go ahead and start to introduce them. Oh, we might have a few, we have one question from the audience that I forgot to include, so I would love to include this. So Bella asks, could you tell when there were more or less pollution in the area, or did you rely solely on the machine?
That's a good question. I'd say all the areas, it's really comparative because like the air quality where the worst air quality areas, it wasn't like bad air quality. It was still fine. Like it's breathable and you would be able to live all your life with that air quality. It's just that parks had significantly cleaner air, meaning like there was like no PM 2.5 like particulate matter or fuel emissions in the park areas, while there was still some in the like other areas.
Awesome. Such a great answer to the question. Thank you for hopping on and answering that, as I just caught it before we let you go and moved on to our last presenter, Walker Rawlinson, who will be introduced by our mentor, Sarah Fanning. And we're so happy to have Sarah with us tonight. She's a very enthusiastic teacher and scientist. So I'll go ahead and let her introduce Walker and his project.
Yes, thanks, Courtney. So I got the honor of mentoring Walker Rawlinson from Sugar Bowl Academy, and it was such a fun time to work with Walker. His project was something I had never personally thought about or worked with. I'm normally a plant person, and he was interested in looking at insects, specifically ants, especially in his area. So it was fantastic to see him go out and do his own field work and collect his own data throughout this whole summer process. And he came up with some really great research that I think can definitely be expanded on when he goes to college and beyond. So without further ado, Walker.
Thank you, Sarah. So my project is on how human presence affects ant ethology. There we go. Table of contents, it's what we're going to go through. Introduction, results, graph, the normal, go through methods, discussion, reference, Q&A. For an introduction, I looked at the carpenter ant, and what is that? More specifically, I look at the western carpenter ant with the scientific name of Camponotus modoc. It is a species of ant native to North America, more specifically the western region of North America. They are very commonly found within the North Tahoe region, which is where I live. And that's also where my experiment took place. Another common name for these types of ants are wood ants. They get this name due to the fact that they create nests within stumps, logs, or within wooden structures within people's homes. These ants, their head, thorax, and abdomen, their entire body, is primarily black in color. Sometimes they have this little stripe, as you can see up to the right where my cursor is, on their abdomen. And sometimes they have reddish legs too, like really dark red legs. And these ants, the average worker, which is what you'll normally see, size between 1/4 of an inch to 1/2 an inch. And in the size of an ant, this is a fairly large ant. How do these ants behave, which is what my experiment focuses on? Western carpenter ants, like most carpenter ants, are nocturnal. This doesn't mean that they aren't active during the day. It just means they're more active during the night. And within almost all ants and these carpenter ants, there are multiple classes within the colony, and each class determines the ant's behavior. The workers are either like foraging in the wild or are working around or within the nest. The soldier class which are usually like the biggest ants aside from the queen. They protect the nest or attack other colonies if they're in like a war. Um, then there are reproductive males, which are the ants that have wings. Their only purpose is to fertilize a queen and die. Then finally, the queen, like the most famous one of all, it lays all the eggs. All the ants work for her, and she starts the nest. And then next, let's go to my research question. And I asked, how does the ethology or behavior of Camponotus modoc change with their nest's proximity to humans? My hypothesis to this was the closer the nest is to humans, the more aggressive the behavior will be, and the more solitary too. And by solitary, I mean more ants will work alone and less as a group. And why do I think this was important? I believe this experiment will help people understand the most common insect around your home, especially in the North Tahoe region, because I focused on that area. I believe it'll also help people understand these ants and understand if they will like attack the ecosystem around them, and if they need to exterminate them if they want their garden to flourish in their backyard or something. And also, it'll help people know if they have to be more cautious around these ants, depending on where they are in the woods or if they're just out on a trail. Then my results. So I found that the nest with most, I forgot to reorder this, methods. I forgot to do methods first. So I found 3 locations for observation. One near human combs, which I called the residential location. One on a man-made trail for recreational use. I called that the recreational location. And one not near any human structure or path. I called that the non-human location. The residential location, the parameters were to be within 25-meter range from a house inhabited by humans that is within a residential area with paved roads. The nest that I found is 15 meters to the right of my house and 10 meters to the left of the neighboring house. So it meets these requirements. And both these houses are on paved roads and surrounded by other houses inhabited by humans. The recreational location is on a trail meant for hiking and biking and just normal recreational use. And this location is roughly 3 meters from the path or trail. And the requirements were within 10 meters of a trail. And finally, the non-human location, the parameters were to be over 200 meters away from any human-made path or structure. And the nest that I found was 290 meters away from any path or structure. How I observed and documented, I found the most densely populated area, which is the area with like the most entrances to the nest that are like closest together, and within each location, and I observed that area for 20 minutes at a time. Each location was in the same region, the North Tahoe region, so they all had a very similar climate and nothing too different between the areas. And then within this experiment, I used observational data, and yeah, I set it up by just sitting down, watching them, and taking notes of these Western carpenter ants. From the data collected in writing, I put it into Google Sheets, which is, I assume everybody knows, it's just like a way to document things. And then once all replicates were completed and imported into the Google Sheets, I found the averages of the prevalence/absence of each behavior, and I calculated that to find my results. And then I took extra notes, as you can see down in this bottom picture. There's like a little notes side, just out of any other outlying behaviors, and I took that into account for the discussion. And the materials I used were just a notebook, pen, computer with Google, and my eyes to watch them. then my results. So I found that the nest with the most aggression was the residential location, with an average aggression prevalence of 55.57% of the time. With the second most aggressive was the non-human location, with an average aggression prevalence of 44.43% of the time. And the least aggressive is the recreational location, with a prevalence of 22.23% of the time. The non-human location, and then for the defensive down here, which is another behavior I monitored, the non-human location was defensive of their nest 100% of the time, while the recreational location was defensive only 50% of the time. And finally, the residential was defensive only 33.33% of the time. And then for the solitary work, which is if the ants are just like working on something alone, then the residential location works solo the most, with it being 100% of the time. And then the non-human location was second most likely to work solo. It was 66.7% of the time. And then the recreational location was least likely, with 50% of the time. The only location that didn't work together, because I also took that into account, the only location that didn't work together for 100% of the time was the residential location, and they only work together 50% of the time. And then as in this bottom right photo, you can there's like down here by my cursor, there's like kind of sawdust, and that was used like from all the ants working together to excavate from this log. And all these little holes and lines are the entrances into this log and nest. Here are the data figures that I used with Data Classroom and the data I collected. Both these figures mean the exact same thing. It's just two different ways of looking at it. On the left, we have the site name on the bottom, so non-human, recreational, residential, and all the behaviors are color-coded. And then on the right, it's just the opposite, with the site names being color-coded and the behaviors on the bottom. So, next, we have the discussion. So how I interpreted this data, so it didn't exactly support my hypothesis of, as you got further away from human civilization, the less aggressive it would become and the less solitary. But it did somewhat support it, with the closest nest being the most aggressive and the most solitary. So wasn't super definitive. And then the nests were increasingly less defensive the closer to humans, which did support my hypothesis. But this could mean that the further away from humans, the more like small animals that they can defend against, like more predators, that they're able to attack and take on. But when they're closer to humans, there are more bigger predators like bears, because bears like trash and humans create trash. So that just creates bigger predators that the ants can't defend against. And that could be a cause for the less like defensive behavior, because they can't even defend against some of these predators. And with all these predators, this might cause them to attack anything that they can when they're closer to humans, because there's less things that they can attack with all these big predators that they're kind of trying to compete with. So they're trying to attack anything that they can, which can make the nest more aggressive. Then in the non-human location, because that was the second most aggressive location, they're more small predators, and there's more things that they can take on. So there's just more opportunity to be aggressive, which is my interpretation of why they are second most aggressive. Then for new nests, the recreation location looked like it was a new nest, like it was like it had just been built or inhabited, and they were just starting to excavate it, because I saw excavating ants every time, and there's always a ton of them just throwing little pieces of sawdust out. So this means that they could have like their priorities differed, and they weren't trying to attack anything. They were just trying to create a home first, because you want a roof over your head before you can eat sometimes. You're trying to be safe before you try to attack other things. And then more spread out in the residential area. What I mean by that is, since there are more big predators that can like squish them or like step on them, they try to be more spread out, which means they have to work alone more. They can't like group up and all work together. So this could cause the solo work of the residential area to be much higher than the rest. And my limitations in this experiment, more replicates, like more observations would have been a lot better. This just would have allowed for more precise and accurate data, because more data reduces the effect of outliers, has on the outcome of the experiment. And then destruction. As you can see here in this photo, that was the residential nest. And it got destroyed on the last day of my experiment. And so it just changes things. I don't know how exactly that affected the ants, because that could have either made them more aggressive or less aggressive. I don't really know. I don't have enough data and knowledge for that. And then, yeah. And then for time, the time given was fairly short. So like I said before, I would have liked more time to have more replicates and just allow for more things to happen within the nest, and for me to be able to absorb it quicker without being on as much of like a time crunch. And then false nests. I encountered a few false nests during my experiment, and I just call them false nests. It's just like my own term. I describe it as where a lot of these ants gather together but like they're not near their nest. It just looks like it might look like a nest, but it's just a big gathering. And if I observed this and I found it wasn't a nest later, this data would be unusable for me, which just hindered me within this time crunch that I was in. Then improvements for next time, if I did this experiment again with less limitations, more time, obviously, more replicates. So, and then weather and seasons, going through multiple seasons and weather patterns would allow for more variety and more solid data in general. Then going through the seasons can help find like when a specific behavior happens and like when it's most prevalent. And then going through like different weather patterns would just broaden the scope and help find any behaviors that are specific to certain states of the climate, and like how like maybe global warming will affect these ants. Then finally, like having nighttime. Like I said before, these ants are nocturnal, so they are more active during the night. And I didn't have the materials like night vision, because I didn't want to use a flashlight, because I think that might disturb the ants. And I wanted this to be as natural as possible. And having this nighttime will just allow for more data because they're more active. Yeah, here references. References continued. And any questions?
Wow, what an awesome project, Walker. As a new Truckee resident, I'm going to be looking out for these ants no matter where I am, near my house, on the trail, if I'm off in the woods, not near any other humans. So, and I know so much more from your research and presentation. I'm going to go ahead and let Sarah ask you her first question. And I know we have a few from the audience too.
Perfect. Yes, I have two questions. So Walker, you talked about looking forward and moving forward, thinking about weather and seasons. What was the weather like when you recorded your data? Did that play any effect on this?
So yeah, during my data collection, it was primarily only sunny. Sometimes like the trees would shade the nests, but there was always blue sky, except for one day at the residential location. It was cloudy and stormy, and from my data collection, it didn't change it that much, but I just wonder what it would be like if it was like a snowstorm or just like a big thunderstorm for like 3 days, and how that might affect them with all the rain and ants with water, how they deal with that.
No, that's great. That's a fun thing to think about, especially moving forward with this. My next question also kind of surrounds those same things about like potential moving forward. How do you think the ants' behavior would change from like spring to summer and then summer to fall?
Yeah, so I think because they're not really going to be as active or like out and about during the winter because there's snow and that covers a lot, especially around here in Tahoe. We had a lot of snow. Um, so I feel like going into winter, like that could like make them more aggressive because they're trying to just get as much food in as possible to store up. And coming out of the winter, it could be like the same thing, kind of like bears. They're more hungry just before and after the winter, or they could be more defensive because like other animals are trying to eat, and so they have to protect their nests more right after winter. Not sure exactly how summer. That just could be like their peaceful period or something. I'm not sure.
Yeah, that's great. Definitely a lot of potential studies to be done with that.
Yeah, lots of areas for you to continue to study this work, Walker. I want to grab Jack's question from the audience, and he asks, did you have any trouble standardizing your descriptions of the ants' behaviors?
So I kind of looked at a couple papers, seeing what they looked at. There aren't a lot of papers out there, especially on like carpenter ant behavior. It's mostly on like how they are pests. So like I didn't have too much trouble, but like getting started and finding which ones I wanted to focus on was a little troubling. But once I had it, it was fairly easy to just identify it when I was out there.
Awesome. It's a great answer to that question, and I can imagine trying to standardize ant characteristics isn't necessarily the easiest task. I have one question for you, and I'm really interested to see what you think on this and how could this sort of study be applied to other insects in other regions?
So yeah, this could be applied to like the most common ant in California, which is the Argentine ant. So that could be applied and compare the two. Or I've seen pharaoh ants out here that compare two ants from the same region, see how they differently interact. Or just using this for like bears or cougars, because I know those are native to California, and just understanding and like how to best be aware of if they're behaving this way, they're going to be more aggressive and all that kind of stuff.
Yeah, well, that's awesome. I know I learned a lot. Thank you so much, Walker. Thank you so much, Sarah. And we'll go ahead and wrap up for the evening. So, as we come to a close for tonight's presentations for the summer 2023 research experience, I want to encourage everyone to join us at the same time, 5:30 p.m. Pacific, 8:30 p.m. Eastern, for the night 3 of our presentations exactly a week from today on August 16th. Another plug, if you or someone you know are interested in joining our spring program, our fall program for the research experience is completely sold out. But if you want to join the spring program, the link is right there below. We would love to have you. We also have a digital data camp that is starting August 21st that I will be teaching, and there's room for more students for this camp where they get to learn about data science and apply it to a mini project. So I'm really excited to be working with students there. And if you think yourself or a student you know would be interested in that, please register at this link as well. But lastly, I just want to say a huge thank you to all of the students and mentors and Headwaters staff that have been involved in the research experience throughout the summer. I know I have learned just as much from the students as they may have learned in class, and I'm so grateful to my amazing mentors that have made this all happen. I really look forward to having any and all of you on August 16th for our last night of presentations. But until then, I can't wait to hear from you, and we look forward to seeing you on August 16th. Thank you all for coming.